This is a beginner's guide to use the LSF functions in Tricalc. To start a new model, you just go to New, select here the precision of the coordinates of joints in millimeters, and define a name for the structure. With this, you have the model open. Here are the general axes. To create an LSF panel over a CAD drawing, you go here to the Tools menu and Drawing function. Here you can select a new plane if you don't have any at the moment. This plane is horizontal and you select a height in centimeters. You can create planes vertical or inclined in the geometry work plane function. Here, for the height you have selected, you can double click and select the drawing that you wish to use. Inside Tricalc folder, you have a folder called Various, where you can use an example file. You can set up the unit, each unit for the drawing, which is the real measurement that it is equivalent to. So with this, you have the drawing associated to the height. As a tip, you can always save your drawing in the folder of the structure. In that case, you don't use relative paths, you just use an absolute reference to the drawing name. Okay, you must select which work plane you want to see now. You could select multiple heights with multiple drawings. So you go here to Geometry, Work Plane, set up the level that you want to see. In this case, we have set up the 0 height. If the drawing doesn't appear at this moment, it can be one of the three things. The plane is not selected. Here I have the confirmation of that. In the tools, the drawing function of the drawing, the draw the function of drawing is not activated. Okay, or you are doing a zoom much bigger than the drawing, so you can do the zoom all, and in this case it will zoom all of the drawing limits. If you need to set up layers for the drawing, you have here the possibility to activate and deactivate layers that you want to use, and also you can change the colors for each layer. You just need to double click or use the correspondent icon to change the color of each layer that you like to consider. Okay, I'm going just to quit also the pillars columns, the columns layer. Okay, so this is a general architectural drawing. You can project the work plane in your view. Here it is, and now you can start creating walls. You can work in any view. To create LSF panels here, LSF frames, you can start by defining any reference point that you would like to use. To help you, you can use also the settings for the grid. You can change the settings. Let's say I want to use a grid line with 60 centimeters of visual spacing and the mouse spacing for 5 centimeters. I'm going to draw lines for this grid. So this grid can be activated or deactivated at any time. I'm going just to change here the color for the layer of the walls to a color that has more contrast to these elements. Okay. Oh. Now, if you want to change the positioning of the drawing with the grid lines, you can do that by giving it new reference points. Let's say you want to move the CAD drawing. You just need to select what point of the CAD drawing you would like to use as start reference, and you can use the grid line as a destination reference. So I want to place this corner here at this position. I use the left mouse button to select any corner, any end line of the CAD drawing, and I use the right mouse button to select any point of the grid line that has the accuracy of 5 centimeters for each step of my mouse movement. You can use any reference that you like. Now, for creation of new panels, you can use the geometry light seal frames. Here you can define a new frame. You can work in this box with centimeters or millimeters. I will always use in my explanation the centimeters. Okay, it has a warning here that the section that I selected is not in my database, so I'm going to change the section. So you have an LSF and database that you like to use. I'm going to select this profile, 145 1.5 millimeters thickness for this general purpose profile. The same profile to all bars, and I will attach this frame to the base. So this is a start panel. If you are going to create a panel, let's say in level 1, it will need this option. For the creation of this panel, I'm going to create a panel, let's say with 2 meters length, and using the spacing of 60 centimeters between vertical elements. For the height, I will use 300 centimeters height, and the height of the horizontal elements, I will give them 1 meter and 10 in height. I'm just going to use this panel none as orthogonal. Let's say no vertex is changed, so every vertex is 0 centimeters, not any displacement to any of the vertex. So you have here the panel 200 in length, 300 in height. The 60 centimeters are placed with this rule. They are at the just length at the extreme end of the panel. And for the vertical, the adjustment is made in the middle. If I want to change this logic, I'm just going to change here to adjust the length in vertical spacing at the top end. Okay. So we have here a rectangular panel. In this case, I can change any of the direction of the profile. You just need to select it. You can view with this visualization, or also you can activate the rendering window. If you select here the simple or double profile, you can also change here by double clicking, or you can select multiple profiles at the same time and use the same icons to change those options. The same thing for the horizontal elements. For the other step, we have here the selection of diagonals. If you want to select diagonals at any place, you can activate them here, or you can deactivate them also here. If you assign diagonals to any panel, you can change the direction of those diagonals, also the orientation of the profile, and also where does it start or where does it end. It will start in the horizontal beam or in the vertical column, or at the end of at the top, the same rules. Okay. Now for the start of the definition, I will just use panels, not regular panels. Also, you have here the possibility to change any of the elements that you like to use. You have here the delete horizontal elements, as you can see here, or you can delete also vertical elements. So you can also delete vertical or also diagonal elements. So it is possible to change the definition of this panel. If you want to restore any of those alignments, you just need to select and activate again where do you want to place the elements, or select multiple elements and activate the vertical bar or horizontal bar. If you have selected for this panel a box beam on top, just going to change here the section to be the same as the other one. Okay, let's use this section here. So I have now a box beam on top of this panel. That editor rendering, here it is. So you have here the box section here. If you don't want the box section in the total length of the panel, you can change it here and select which elements will have or will not have the box beam. So if you just want to use the box beam in part of the panel, you just need to select where you like to use it. So the panel is ready to insert. The insertion point, you can define it by clicking here in the insertion point, and in the panel here you can define which is the elements. If to rotate the panel with the function activated, you just need to use the shift and control keys with the mouse button. Shift wheel of the mouse and control wheel of the mouse. So in this case you can change the direction and visualization. I'm going to use here the corner. I'm going to change here the view. Okay, orbitate, and I'm going to insertion point. I'm going to create it here at this position. Okay, so that's the place where the panel will be start to be placed. The destination of that point is placed here. Tricalc will always insert orthogonal panels unless you activate this option that will allow you to insert non-orthogonal panels. So I'm going to use this for the vertical plane. I'm going to create this panel here using, for instance, this point here for reference, the corner of the wall. Okay, and now I just need to use the direction. To select that point, it is an end line or intersection of lines, so I can use the left mouse button. Here I could use here the left mouse button to select another line, or just the right mouse button at any point of the grid here, because the direction is locked to the orthogonal position. Okay, so it is created. I'm going to insert here a vertical plane also at this wall here, at this corner, and place it at this direction. Again, I'm going to insert here, and now I'm going to change the position to the other corner. It's more easy for this insertion this position. Vertical plane. I'm going to use here this position here. Okay, and now I'm going to insert here another one from this position here. As you can see, we have always used 2 meter length walls for an example. Of course, you could change the length of the panel to any other length that you'd like. So it is possible to modify the frame or even in the definition. When you select here the length, you can select here in this double arrow 2 points, and in that case 2 points, and in that case it will select 1 and 2 points for reference, and it will measure the length that it will need. So it is a possibility to change or define the panel with another length that you like. But it's much easier to use the adjust junction between panels. This way you can adjust the junction between 2 panels with the rules that you have here. For instance, I'm going to use this rule. The first panel, which will be the one that will be continuous, and the second panel will be the one that will be interrupted. So panel 1, panel 2. Adjust. This is panel 1, for instance, this is panel 2. So you have here the connection made. You have here, for instance, this is panel 1, this is panel 2. This is panel 1, this is panel 2. So you have the connections being made automatically between them, the length corrected. In this case, I took any measure to correct the positioning of the vertical elements, but I would like that the vertical elements will be 60 centimeters apart from each other. So in this case, I'm going to activate the rendering to help me view set rendering window to view the structure. So as you can see, the line of the grid is not aligned with the vertical element because I took no care for that. But we could do this another way. You could use the function of move element, and you can move the center, the side of the sole, or the opposite side. What is the reference that we'd like to use? I will use the center part. I will select the elements that I would like to displace, and I will give a new reference line. Of course, I can use the right mouse button to select a point of the grid that's over the line of reference, so it will automatically correct it. This way, I can do the same thing for the other panels, and it will be all vertical elements aligned to the position. To move this visualization of the structure, during a command, during your operation, you can press the Alt key, and without releasing it, you can use the left mouse button to orbitate the structure. Okay. In this case, I have here two different alignments for reference. As you can see, this panel, because of the rules that we have created, has a different disposition for the vertical elements, but we can do always the same rule for positioning. This function is also available for the horizontal elements. In this case, I see no need for that the existence of that point, that post over there. So I would like to delete it. I can make that deletion from two ways. I can just delete the element and graphically do that operation. It is done. I'm going to undo. Or we could change the panel, modify the panel here, and we can delete it here. Delete the vertical bar. So in this case, we made the change inside this wizard, this assistant. The same result. So if you like to create here a top slab, the procedure is always the same. So you go to define frame, select here rectangular panel. You can define measures if you'd like to define specific measure or measure it from the drawing. You could measure the length there. You can give the rules, what rules are to be used to place the vertical elements. So I placed here 60 centimeters, and then the rules for those positionings where the adjustment must be made. Okay. And the same thing for the heights. We can do the same rules for the heights. Okay. So with these operations now we can create a new panel and insert it as a slab, let's say in the horizontal plane. This way you are going to create the insertion point. Let me change the insertion point here to another place. I'm going to search here, for instance, for this corner. Okay. And I will place it in a horizontal plane. This way, when we select here the point of insertion, I will select that corner. Pay attention that we have selected the plane 0, and you see the vertices here. The vertex are here to select, but they are not here on top. Why is that? Because the plane is locked in the plane 0, and the top of the panel is not the plane 0. You are seeing those panels because it is activated the function here in the visualization filter to show the upper active plane. So if you don't have this option active, it will show just the elements that belong to the plane 0. With this option, you see those that start above that panel. Now, if you want to see the top panel, you could, of course, select here in the planes window another plane. Here it is. Or just easily, you can just disable the plane. So you see all the structure at the same time. Now I can select everything, every vertex as a reference. So I'm going to select this first corner as a first reference. For the definition of the direction of the alignment of the panel, I'm going to choose another vertex in this direction. And for definition for what side of the creation of the panel, I'm going to select here this point. So I have selected always with the left mouse button the vertices that are available. Now the length of the panel, just by luck, it will be the same, but it's not correct, of course, and it's not okay. So I need to change the length of this panel. For that, I'm going to use the same function, adjust junction between panels. So I'm going to use the same rule, 1, 2. The 1 will be the slab, the 2 the wall. So the first the slab, the 2 the wall. First slab, 2 wall. So it is fixed, that connection. If you are going to connect to a different panel, it will be, let's say this wall, it will support two slabs. So you can just select this option, and with this option, the connection it will be made just up to the middle of the wall. So it can receive another panel at the other side. If you want to have a clearer visualization, you can go to the rendering options settings here, rendering settings. And you, for instance, can hide lines. In this way, you can see just the visualization of the possible to view lines, not the hidden lines. This is not a work mode, it is just a visualization, so at any time you can restore and view everything else again. Of course, rendering is also optional. For the reference of the elements, again, the rules are the same. So you can just change the positioning of the slab elements according to the the grid line that you have defined. So if you want to change here the plane of that grid, you just need to go here to geometry, work plane, select the plane for a work plane from the frame LSF. Just select the frame that you like to use to view at any time. And now let's say I'm going to project this work plane in my view here. Now you can see you can align differently your profile. So you can go to the same function we have used before, move element, and select, let's say, in the center of the element, where do you want to place it. So you have here that positioning that is available. In this case, I'm using the axis of the profiles as a reference. So here it is. Well, this model is completed. If you want to view drawing options, you have the possibility to draw the panel name, draw the point of origin, that's the fixed point of the panel where the length will not be changed. And also you can redirect bonding elements between frames with a different color. Also, if you use different profile sizes, you can use different colors for each type, each size of profile that you are going to use. Here, the blue lines represent that these connections are automatically created for the structural model. Okay. In this case, this line here is not blue because we are expecting to have another panel there, and only in that situation will be complete the connection. If we change the connection type, let's say for this one, connect this panel to this one, then in that case, it will automatically recognize the connection as terminated. You can at this time create a structural model if you'd like. Here, create the structural model and test it. So this will be a quick way to test your structure if it is doable, if it is viable, if you can test it correctly. Here in the customize menu, you can select your work language. Also, you can select the structural code that you are going to use. Also, here at the computation, you have the materials that you are using for the structure. If you are using concrete, if you are using structural steel, wood, or other kind of materials in other elements in the same model, you can define every of those materials. Now, if you want to create here for the panel hole lines or fixing lines, you can define them here. In these vertical panels, we have created to define fixing lines. So you can insert fixing holes or delete fixing holes that are already created here. Let's say I want to delete a fixing hole. I'm going here to this fixing hole that's here. I want to delete it. Just need to select it with the left mouse button and it is deleted. If you want to delete more than one, you can just use an elastic window with the right mouse button. You press the right mouse button, drag it, and release the right mouse button after the window is opened. All the elements inside the frame, inside the windows, will be deleted. Now here in the insert fixing hole, the rule is the same. You define which type of fixing hole you would like to use, accept it, and afterwards you can select also the work plane. If it's easier for you, select the work plane of the panel. Okay, and I'm going to place in this line, select a line, and in this case I'm going to use the right mouse button to place new fixing holes. Okay, it's going to have the accuracy of 5 centimeters. That's the rule that I've set up it earlier in the grid lines. You can use a CAD drawing as reference or other reference that you like to use. You can also use the members and joints to reference points that you like to use. Now, to create whole lines, I'm going to disable here this work plane. Let's say I want to create in this frame I'm going to select here the work plane of this frame. And now I want to project this work plane. I want to create here lines. In the functions of light frames, you have here the possibility to enter whole lines. You can select the tool that you like to use, accept it, and now you can use as reference with the right mouse button any alignment given by your grid line here. I'm using the right mouse button to select points from the grid line, and I have here the holes inserted. Also, you can insert here a CAD drawing in this vertical plane and use it as reference for creating your holes also. Enter the whole line. If I change the tool, for instance, I'm going to set it, and I'm also going to change the rules here of the grid line. So here in the settings, I'm going to my mouse to create alignments from 20 centimeters multiples of 20 centimeters. So when I'm going to create here a new line, it will have always 20 centimeters reference distance between two lines. So it is nice to separate columns or separate lines, whole lines with that reference. So you have here all the holes placed in the profiles. Now I'm going to disable this work plan. Disable, Control D. And now for the explanation, I'm going to create here an opening, a door, a window, any kind of opening that you like to create it. You can set up it in many ways. You can set up it in the wizard, or you can set up it graphically. So I'm going to do here a whole of this door the two ways. First of all, I'm going to create it for this door that's here. That's the door. Okay. I want to create that opening here, and just going to change here the drawing options, not to use the green line, the green color for these profiles. So I'm going to create this door here the two ways. First way, with the wizard. I can see the objective, our purpose is to create here a new profile here at the left and a new profile here at the right of the door, and terminate the wall, let's say, in this horizontal beam here. So for that purpose, I'm going to modify my frame. I'm going to create for this spacing here two new elements. So for that, I can go to the distance here. So I have here a 50 centimeter distance. I'm going to divide it, split it in 2 of 25. Also, I have here a 60 centimeter distance. I'm going also to split it into 30 centimeters spacings. You can use the space bar, the space, to separate the values. So I have here all the new elements that I would like to use. So I have them here. Okay. Now I just need to replace this or place these elements where I like them to be, using the same functions that we have used before. Move element. I'm going to move the center or the side of the sole or the opposite side of the sole for reference for this positioning. Now I'm going to position this, for instance, in this point here, using the CAD as reference, and also this one in this position here. Of course, this one is in the opposite side. Let me change it, the rule. Okay, and now this option here is done. Now just see that the opening of the profile of this side is okay, but the opening of this profile is not okay. It's the opposite. So I can modify the frame and change it. So going here for the element, this is the element I would like to change. I'm going to here C to D, or in this case D to C, the crescent to crescent. So here it is. Now I just need to delete the opening for the door. Okay, I can see it here. So I just need to delete this vertical and this horizontal element. So you just go here, modify the frame, and delete the vertical. You can do this all in one operation, and I'm just explaining it. So I'm doing it in several operations. Also want to delete this horizontal here. So this is the final panel. If I want to create diagonals, anything else, I just go to the correspondent menu here. Let's say I want to create here a diagonal at the top level. Just insert here a new diagonal here. Okay, and I also create the same thing in the other one. So doing the same thing. Okay, change the alignment to another direction. So I want to use this. So here it is, that option we have created. So this is a way of doing it with the system, the wizard. Now I'm going to restore this. Okay, and I'm going to do this operation using the graphical functions. So for the graphical functions, okay, for the graphical functions, you can use this. enter element, delete element, split element. So I'm going to enter new elements for the vertical bars. I'm going to insert them in one point, and I can select here the direction of the insertion of the profile. In this case, I'm going to insert the vertical starting here, ending here. You define the start and end, and afterwards you define the insertion point. Now I'm going to do the same thing for the other position. Here, start here and here, and now the insertion point. So the elements were positioned. Sorry, I'm going to undo it again. Okay, I didn't notice the positioning. So enter element, going to change to decrease the decreasing. Start here, end here, and now place it in the corner of the CAD drawing. As you can see, the profile is in the correct position. Now I'm going to change the position for the second one here, and start and end, and now the placing position. As you can see, it used the axis as a positioning for that element. You can change this very easily, because if you use the move element, if you move the center of the element, the center of this element to this position, to this corner, it will be correct. If you move this element, the center of it, for this extreme position, that will be the new center, so it is correct. So you have here at this moment the two new elements inserted graphically. Now I'm going to go to the work plane for visualization, select the work plane of this frame. We can project the work here. Now I just need to divide the elements that I want to split, the elements that I want to delete. So for that, I'm going to increase my precision here for 1 centimeter with my grid line, and I'm going to, or I could snap disable the snapping, so the mouse button isn't locked to the grid line. And I'm going to use the graphical functions of split elements. So I would like to split these vertical elements, not in the middle, but below here after the middle, so that the top bar will continue after the middle to a position, approximate position here. You don't need to be very accurate with this, because this is just a 3D model. The fabrication and beam, which will be calculated by the software, by Tricalc, the correct length for all parts. So here it is the same rule. I'm going to go after the middle for this one, and when this is one I want to keep, so I'm going to go after the middle again, and this one also to divide, the same rule here and the same rule at this point. So I've made the division of the splitting of those elements. In this case, I just need to delete the parts that we don't like to keep, that you don't want to keep here. So here it is, the same door here. If I want to insert the diagonals, the process is the same. Enter new element. You can insert an inclined bar. You can define the orientation of the profile, and for that you define where does it start, where does it end. I want to start in the beam, I want to end in the column. Now I'm going to select the two vertices, where does it go. So as you can see, start in the beam and in the column. Now I'm going to start in the beam, a new one, and end in the beam from this point to this point, and it will automatically create in that orientation. So we have here the same case made now with graphical functions. So as an advice, I can, as you can see, the work for creating an opening is not too much. So, but it is most important that you first design a solution that works. So we always recommend, for the first time to create the structure, you don't need to mind much about openings, only if they are very, very, very big. You can create a quick sketch of your model and test it, convert it to a Tricalc model, a structural model. Okay, in this case, I'm going to disable here the light seal frames here, and we have now, I'm going to disable the work plane also to see everything. Okay, here it is, the structural model created automatically with the, I'm going to change here the scales. The scales, let's say I'm going to use just 3 centimeters. So we have here all the sections that are created, all the joints, all the members here. And you can see that these circles here represent the types of connections. There you have it, GX1, GY1, GZ1. and get the same thing for the second position. The first position is the smaller number, the last position is the higher number. And you have here all the model created, the supports, everything. So it's ready to calculate. You can insert loads, you can create other things that you'd like to test your structure. For these panels that so for this structure, after you verify that structure is doable, the structure is okay, then you can start producing your light steel frames. So you have here the light steel frames, and for that you can obtain here the reports where you can see and measure all the light frames here in manufacturing. So here it is, all the panels you have created are here defined. Here are the holes that you have created. Here are the other panels that we have here. So this is the one with the opening, everything. This is the fabrication model. So the manufacturing you have here for each element. This is the H3, the horizontal 3. You have here all the operations, screw hole, lip cut, section step, everything, section reduction, every component that is used there represented here in the drawing and in the fabrication lines. Now you can create the manufacturing files for your machine in this model, in this function. Also, you have here the possibility to export the beam model. You can export the complete structure or just the selected branch that you have here. The branch can be a construction phase, an execution phase, can be elements that you have selected. So it is possible to create all those filters. Here you have also, I'm going just to open the EFC file that I've just created. So here it is, the EFC file that we have created, and all of the lengths of the bars are accurate to the fabrication that is going to be executed now. Okay. Now you have also the possibility to generate the report of these steel LSF elements. Here in the report, you can include the options that we have here, all the options that you want to activate or deactivate here for filtering. And you have here your report all format, all with the layout all set up. You have the quantity takeoff here, the number of screws, the number of fixings, and the drawing of the frame is also here. All the scales are configurable, so you can select the text scale, everything. And you have here the panel for the assembly, and you have also the positioning. What panel is that? Just going to change here the page. What panel is that? That's that panel in that position. What's the facade looks like? What's the elevation? And the positioning in 3D where that panel goes to. So you have all the drawings for this. This can be obtained here, or you can obtain it also in the drawings section here. In the light steel frames, you can see all the drawings for all the panels. In this case, you can also export them to CAD or directly to the printer. So you have here for the steel elements, the settings, where you can change the printer or any kind of file type for export. Also, you can change here the text height, for instance, and you can change here the options, the scales, everything of these drawings and how are they, let's say, are they managed here for presenting. So you have here all the settings that you want to change. If you want to draw some drawing or not, what's the level height that you want to display. So it is possible to change here the options. Okay. Here for the logo of your company, in the properties here, you have the possibility to, in the customize, you can define your company logo, but in the properties, you can change all the information for these structures. So you can change here the text for the project, structure, auto organization, also select drawing for the logo of your company. In this case, you can select any kind of image. You have many file types, BMP or JPEG, that you can use for reference, let's say. and it will display your logo in all the elements. So this is a general beginner's guide to use for Tricalc LSF functions. If you had different models that, let's say, another floor to create here, another level, you could copy and paste elements. For instance, I want to copy this panel here. I'm going to disable here the structural elements. Just copy the frame here and escape key, define the insertion point. Let's say this point here. And if you want to set up a direction, you can set up it now, but I don't want to use any and escape. That direction, which will be helpful if I want to paste and rotate. Okay, I just want to paste simple and define the insertion point with no need for rotation. If you need rotation, you need to define a direction. So it is a new panel created over the slab. I hope this video is helpful to start with the usage of Tricalc. Also, I recommend the consulting of our technical support and tutorial sessions that you have available. Good work.